Welcome, everyone. I'm Antonio. I will be your host today. Today, we are launching Data Architecture Elevator Espresso, which is a new format that will live alongside our original Data Architecture Elevator podcast. The aim of this new format is to create episodes as short and concentrated as a sip of espresso, obviously. So, today we will revisit some topics on data streaming that we left behind some time ago. And we are with our dear Andrea. So, let's present yourself.
Hi everyone, I'm Andrea Fonti. I'm a data architect at Agile Lab, and my focus is usually streaming pipelines and stateful streaming. Thanks for having me. Let's focus on Kafka. That is maybe one of the most common streaming infrastructure that we find on our customer systems or in the work we usually do at Agile Lab. So we have mostly two kinds of encryption that we should talk about. So encryption in transit, data is in flight, you are streaming data, so there is network transfer involved, and you need to take care of encrypting that. And also encryption at rest. So data that lives on disk should be encrypted as well. So if we focus on Kafka, encryption at rest is not taken care by Kafka itself. Kafka will write data to disk, but you can leverage and employ full disk encryption for that. So, for example, if you are on a cloud provider, you can ask for encrypted volumes, so you will get encryption at rest for free. You should also take care about encrypting backups as well, and not only the data that is currently live. And then you have to focus also on encryption in transit. This is especially useful and especially needed when you are on cloud environments. The network is not yours, not in the common sense at least. So having encryption in flight is a good idea. For example, in Kafka, you can use a couple of mechanisms for encryption in flight. You could use SASL, so Kerberos negotiated encryption, something like that. Or you could use TLS, transport level security. What I usually see in the wild is that what is used is TLS with mutual authentication, and this will take care also of authenticating clients. One of the challenges, let me say, of having mutual authentication while talking to Kafka is the provisioning of crypto material of certificates, certification authorities, and everything that is related to that. But you will get, I think, the best level of security that you can expect by using that. Once you have mutual authentication in place, you can talk also about authorization. That is something that is as critical as authentication, let me say. Kafka has a built-in mechanism to authorize consumer, and that are Kafka ACLs. So once the consumer has a stable name, and the stable name of the consumer is the name that is written in the client certificate, something that cannot be forged, then you can use ACLs to properly authorize consumers to read topics, to read consumer groups, to write consumer groups, and also other systems that could be part of the Kafka ecosystems, like a schema registry. For example, if you're streaming Avro, you need to take care about encrypting and securing that as well.
Yeah, maybe so we touched both encryption, authentication, and authorization, and maybe this is a critical point. So uh, I guess that by default, for example, schema registry is not automatically federated with Kafka ACL. So you will need to take care to give, let's say, authorization that makes sense on both platforms.
Yeah.
But probably if you resort to platform as a service like Confluent that is granted by the platform itself. Anyway, a good point to keep aligned the two systems. And what about auditing? So we need to understand who accessed which topic when for compliance reason. Probably. Do you have any insight? Do you have any experience on dealing with that?
Yeah, on Kafka, that is not something you can do easily out of the box. You can authorize consumers to consume a topic, but for Kafka, topics contains opaque data. So byte arrays, Kafka does not have a notion of what messages actually contains. So maybe you could extend in some way the broker functionalities. There are hooks that you can use. Let's say that we want to keep vanilla Kafka. Then you need to do, in my opinion, something on the client side. Also, auditing is usually related to a broader picture, so maybe an enterprise architecture or something that is pervasive in a particular kind of company. For example, a banking sector player has some auditing requirements and monitoring requirements that could be different for maybe a player that is doing IoT, something like that. So what I usually find in the wild is that each player has different auditing requirements, and one example I can make is in the banking sector. There is a notion of this, let me say, distributed tracing, kind of where each item that is downloaded from Kafka, each message that is seen from Kafka is sent on another topic with consumer information. So I'm consumer A, I consumed this message from this topic, and I will send some kind of receipt on another topic. Then you could make the objection how we are auditing the consumer if the consumer is collaborating with us. For me, it's a matter of integration in a bigger framework. For example, this player does use Flink, but not vanilla Flink, a prepackaged framework that is suitable for the need of this player. Developers are not able to write vanilla Flink job. They need to be integrated with this framework, and then there are checks inside pipelines. Yeah, you're using this framework. You're not putting an application that is not well known. And so when you have integrated your streaming workloads inside the bigger picture of your enterprise architecture, maybe extending data sources that are already available on Flink, doing that by wrapping data source or in line with the jobs, then you can integrate this kind of auditing needs inside your infrastructure. But my take on this is there is no one size fits all. Also because usually this kind of system do not have a data model on what you are actually streaming. Data is opaque. So there is a need for collaboration between the various pieces of your architecture. Once you get this level of integration, then you can process the integration data, the audit data. For example, in CDP on Cloudera cluster, there is Ranger, there is Atlas, there are systems that are integrated in a similar way with other Kafka topics. And then you can analyze whomever did what and to which data. It's difficult to reach to the granularity of the single message because the cardinality of the audit data will be similar to the data you are processing. So if you are processing a huge number of messages, you will get a huge number of audit records to process.
Yeah, it's like you're multiplying your problem by a factor of two at least.
Yeah.
So you need to be very careful on what you want to audit. because maybe the audit outgrows your data. Okay, so we are talking about custom integrations implemented by on a use case, well, on a, let's say, on a company basis usually, or a team
Mhm.
basis, and not something we can just plug and play. Maybe we can touch one last part that's related to security. Otherwise, this coffee is going to be more coffee than than an espresso, which is kind of related, and that's data masking, as you said correctly, Andrea. The data that flows into Kafka is untyped. There is no data model known to Kafka itself. So how can we implement some sort of data masking on a streaming pipeline or on Kafka topics, which is our let's say storage unit?
Yeah, we can do a couple of things. For example, if we want to hide messages to a consumer in an atomic way, so let's hide the whole message. What we could do is encrypt the message before sending it on Kafka. On Kafka, messages usually have keys, so messages that talk about the same phenomenon have the same key. This is something that is not mandatory, but is usually the way. We could have different encryption keys for different keys on Kafka, so we can grant access to different portion of the stream. Let me say, let's make an example. The key of the message is the customer ID. You want to grant to a consumer access only to a subset of the customers, not to the whole stream. Then you can encrypt the message talking about a customer, for example, with a customer specific key, and then grant access to decryption key only for the subset of customer you want to grant access to the consumer. Another thing you could do is agree between consumer and producer on the format of the message. So let me say, let's send and receive JSON message, or let's send and receive Avro messages. And then what you could do is granting column level access. If you do the same thing but with column specific encryption key. So, for example, if we have a column that contains sensitive information, sensitive data, we can have encryption keys that are for columns, not for rows. So, a message is like a kind of row. So we talked about encrypting rows belonging to different customers, for example, with different keys. We could have an agreement about these messages have 10 columns. Let's have 10 encryption key, one for each column. And then I will grant you access only to encryption keys that lets you decrypt the column you are interested into. This is also quite useful for GDPR matter because Kafka is a distributed commit log. Once data gets into Kafka, you cannot delete it. It will defeat the purpose of Kafka. But if you have stringent requirements, like if a customer asks for deletion and we have to do that in 1 day, and your retention on Kafka is 30 days, you cannot do that at all. But what you could do is employing a technique called crypto shredding. Sorry. Let's just forget about the encryption key of that message, and then you have opaque data on Kafka that you cannot recover anymore. So it's a kind of deletion. I think it has also stronger guarantees that software-based deletion data is not readable anymore. And then the problem moves on key management. But key management is something where we know that we need to take care about it with different instruments and a good approach.
Well, yeah, I agree on your your view of the problem. I would ask to you if there are any ready-made frameworks, libraries, or tools that we can use to implement that, even if probably I already know the answer.
Not something that is quite standard, not something that I'm aware of at least, but I think the idea is something good since a lot of data format, also open table formats or file formats like Parquet, are starting to implement something similar for column level encryption. I think that the approach is a good idea, so that could be reused also for streaming. Anyway, it's a matter of integration, in my opinion. No actual systems that do that exist that I'm aware of.
Yeah, probably a good starting point would be to look at extending Apache Avro or JSON with some kind
Yeah.
of new standard, and then also we need to push this kind of information at a registry level, catalog level, whatever, where we can actually classify data and then have the key uh, dance and management up to date at every time so that consumers and producers can use them effectively. Okay,
Mhm.
so I think it's time for us to wrap up. Thank you very much, Andrea, for being here and giving us your insights on data streaming. And see you for the next coffee break. Bye.
Thanks for having me. Bye, Antonio.